Designing bit week 1. Over the course of the week, I came up with various designs, but out of all, this one was the best. What happens in this design is that in the center part you see a servo motor attached to a pulley which is attached to a gear. But now this gear is attached to another one which will turn anti-clockwise. So now what happens is these gears will be attached to the left and right stands which hold the mini motors. And this way what will happen is that the either sides will get lifted up and it will create a helicopter like structure. But this obviously was too complicated to execute, and therefore instead of thinking from drone to helicopter conversion, I thought helicopter to drone conversion, and this is exactly what I did. Now if you look inside the box, there exists a servo motor connected via a linkage system to the mini motors on either side. The left side mini motor would be dragged across the half of the box length, and the right side on one position will be vertically standing and the other way around for the helicopter horizontally. And this is exactly how we are going to build it. So let's get to it. Now we need to build a slider for which the mini motor can be inside so that it can slide from one position to the other, and that is exactly what we are doing right now. As you can see, I have made a lot of changes over here, but I couldn't capture it on camera because it was a lot of work. So let's look at what happens over here. I have made a slider and I have attached it over here. But now, if you look at this, if this slider did not exist, what would happen is if the servo motor is attached with a linkage system to this mini motor. So what would happen here is if this system wasn't in place and only the linkage was here, so imagine this is the motor is at the end. So if this was like this and the servo motor is attached in this bit, then if the servo motor moves, as you can see this linkage system over here, the this mini motor, instead of moving like this, it would move like this. So that's why if you see over here, there's a barrier which I have put so that it prevents it from happening. And for further improvement, rather smoothness, I have attached another small rod which will make sure that this motor moves with ease, because if this rod wasn't there, the motor is just going to sink in through the cardboard, if you see here. Now if you look at this linkage system, this was a bit of a problem when I was trying to design, but I got the design eventually. So what I did over here was to add another linkage system over here. Now if you see the linkage rod attached to the square piece, you see this is movable. So what happens is this converts the linear motion into circular motion. Now there is a rod attached to this circular piece itself over here, if you can see. Now this rod will be attached to this mini motor, which happens to be magnetic, as you know, and this rod is also attracted to this motor. So when I move the circular piece, this will also happen. So what happens is this rod pushes this mini motor, and this happens to move over, and that is how it's done. So to keep the motor in place, you see over there a plastic tube, right? There's another rod which will keep the motor in place, which so makes sure that the motor rotates vertically and horizontally. And to make sure this is locked in place, because when you build up thrust, what happens is the motor happens to move away from the whole body. That is due to the fact being the motor is not attached to the body itself, and it is only attached to this circular piece over here, the cylindrical piece. So it tends to fly away itself. So this extension bamboo stick will lock it in place when we design a locking system for it. Now after we build the whole system, we need to power it, right? So these wires are there, and these wires need to be long, because when we lift it up, the whole system lifts up, the wires should not be short such that this system will bring itself down. So these wires need to be long. After you upload the Minimotors code, this is what you get. Now you need to check for something immediately after uploading the code, is that you need to keep your hand above the motors to make sure whether the motor is becoming a fan or whether it is actually generating thrust. This is to make sure whether the whole system is moving upwards or whether it is moving downwards, because the polarity can change whether the motor acts like a fan or whether it is generating thrust. So better to make sure before doing anything else. Now we are going to set up the initial position of the servo motor, because when we are uploading the servo motor code right away, we do not know what the original position of the servo motor is, right? So we need to make sure it is in the perfect angle. So first remove your linkage system, then we have to upload the code which we will finally set up to make sure the final code works properly with this. So the code. Oh shit. What we are doing over here is to get the physical structure of the servo to the 90th degree by re-uploading the code over and over again with the change of the initial position in the code every time we upload it. So that means we change the angle in the code every time, so that once we upload it, we get the angle as close to 90 degree in the actual physical structure of this whole project. Also, when you are connecting this bit magnetic piece, you have to just make sure it touches. If you see over here, when it is touching, just touching, and I am moving it like this, it is moving properly. You see, this touching bit is pushing and also pulling because it's magnetic. So that is working absolutely perfect. Did I mess it up? This is. Throw it up in the air, will it work? Shit. Right. able to move on its own, it wants to fly. I am adding a 9-volt battery in series with a lithium ion battery to see if that makes any difference. This now. You can see there is no difference at all almost in the cases. That is due to the fact that lithium ion battery has a different internal resistance rather than the 9-volt battery. Hence the 9-volt battery has a higher internal resistance. That means that the current is finding it easier to go through the lithium ion battery and hence bypassing the 9-volt battery, making little to no difference in the output. Over here I have added two of the 9-volt batteries, which is 18 volts but only 0.5 amps, and this is also a little less on the output because it has lesser current, so it doesn't make a difference really. So what's the conclusion over here? Conclusion is that we just need more power from the lithium ion batteries. That is, we need more lithium ion batteries in series and connect them. This thing will soar high. But this mini motor is rated only for 3.6 volts and we are going to supply more than that. You don't believe it can hold that much power? Look at this video where I strain a 12-volt motor to operate at 63 volts and it held up brilliantly. So check it out right now and you can continue this project without any care.